Hi, welcome back to AP Physics C Mechanics, Unit 2, Dynamics, or also referred to as Newton's Laws of Motion. In the last video, we looked at Newton's first law. So, sequentially, you think that we actually addressed the second law. But we're going to stay here. We're going to go to the third law because the second law is when we start getting into the mathematics of Newton's laws of motion and forces. So we're going to look at his third law, which is often referred to as the action-reaction pair, or simply, sometimes people refer to as Newton's golden rule. So the reason why we say that is whenever one body exerts a force on the second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that exerts it. And so the way we think about it is, for every action force, there's an equal but opposite reaction force. So that's why we call these pairs action-reaction pairs, because it's an action force and a reaction force, right? And so when we look at Newton's third law pairs, and you see it in a picture here in a second, we just call them action-reaction pairs, right? So again, this is Newton's third law of motion. Now, mathematically, there's a little bit of a mathematical formula here, but it's not like anything big. We're just saying that if we have two forces acting, right, if we have one force exerted by object A and object B, it's going to be equal but opposite to what B exerts on A, okay? So the classic example is if I put my hand on a wall, right? Excuse me. I am exerting a force, right? So force of hand on wall. And now what his law says that the wall is going to push back on me, right? So force of wall on hand. Now, sometimes students will think that these forces ultimately, or that they cancel out, because once we get into problem solving, you'll see that we do have forces acting on objects. But people think that these will cancel out, but they actually don't, because, for example, the force of the wall in the hand is acting on my hand. Now, on the other side of that, I am acting on the wall. So kind of like my systems are different, right? So my hand is pushing on the wall from outside of the wall system, and then the wall is pushing back on me from outside of my system. Same thing here with the swimmer, right? So you can see that they're pushing off on the wall, but then the wall is pushing back on them, okay? And the reason why we see her acceleration is because she's much smaller than the wall, right? But yes, there would be a force on the wall from her feet. Again, this is her system, and then this is the wall system. So like they're acting in different systems, as opposed to what we have here. So you can see that this is identifying action-reaction pairs versus Newton's third law pairs, okay? So here, these two forces are exerted on the package, right? So they're on the same system, hence the reason why they are first law pairs. But what happens is this weight, which is what we call weight, is actually coming from the Earth, okay? So those would be our Newton's third law pairs, right? Because they're acting on, the Earth is pulling the package down, and the package is actually pulling up on the Earth. And the same thing here, right? This S force, okay? This is eventually we'll call it the normal force, but you can see that the S, right, is the package is exerting a force on the scale, and the scale is pushing up on the package, okay? And so those are what we call, this is our third law pair, right? Because they're coming from outside of each other, okay? So Newton's third law, kind of just to sum this up, it's just action-reaction pairs. You may be asked to identify action-reaction pairs in like a multiple choice question. I've seen that, especially on the AP Physics 1 exam. It shows up here. in the same manner on AP Physics C. But just remember that you're looking for a couple things. One, they have to be acting on different objects. If they're acting on the same object, they are not action-reaction pairs. They are actually first law pairs. And then the other thing is that they have to be of equal size, right? Just pointing in opposite directions, because that is what the law says. For every action force, there's an equal but opposite reaction force. Now we'll go back into again, third law is more conceptual based, right? And also, they will come in handy when you have these what are called connected objects, right? So if I have A and B, well, A is pushing on B, B is pushing back on A of the same magnitude, right? And if you know the acceleration of the system, you can figure out that for the forces which they push on each other, right? Because you can identify those as action-reaction pairs, which means if I can find an F of B on A, I know what F of A on B is. Okay. So now we're going to go into like the kind of nitty-gritty of this unit, where we're looking at Newton's second law, because everything past first and third law, right? It's all applications of Newton's second law in some way, and some applications of first law, because if the objects, or if we talk about constant velocity at rest, right, that means our acceleration is going to be zero, which actually then just turns it into a Newton's first law problem by summing the force inside and then equal to zero.